Hello and welcome back to Azure Terraformer. This is part 2 of my reaction video for the September Azure Terraform community call, hosted by the product team at Microsoft Azure, responsible for Terraform, my colleagues Stephen Ma and Mark Gray. In my last video, we looked at some of the updates from the product team themselves, mainly related to the AZ API provider and a couple other tools that help making use both the Azure RM provider and the AZ API provider a bit easier. This part is dedicated to a community presentation given by Dominic. This is actually the second time Dominic has presented to the group. I think back in August, Dominic gave a bit of a presentation about what we're going to see more of today. And I reacted to a little bit of what he said last time, but this time we're going to dig in pretty deep. Dominic came prepared with 2 demos, one of the code generation tool and another of his Terraform visualization tool, 2 tools that he is independently developing, which is pretty cool, quite ambitious of a feat. And he also came prepared with a slide deck to share some of his insights into infrastructure as code and how his tools might be used in an infrastructure as code workflow. I react to some of the ideas that he shares, give my take on things. Again, in the spirit of community, these are just my opinions. You might have opinions of your own. If you do, let me know in the comments section below. Love to continue the conversation because some of these topics, to each their own. Who knows? But that's one of the great things about coming together as a community. We can talk through some of this stuff and get different perspectives on things. So without further ado, let's drop into Dominic's presentation.
Does anyone have any questions or topics or things they want to bring up?
I have some stuff I can share.
Go for it.
All right. So I talked about this a bit last meeting. There's some tooling that I've been working on, and I received permission that I can share it. So let's see if I can get that.
So this is Dominic from last call. I think I actually reviewed like that and we got a brief foray into this on the last community call. So Dominic's back at the well. And I guess gonna share us a little bit more details. So
that to work.
Awesome.
Can you see my screen?
Yep.
Perfect. So the tool that I've been working on is 2 parts. The first part is trying to automate the process of converting existing infrastructure into Terraform code, and then the second part is trying to visualize some of that. So I have the tenant from my Visual Studio Enterprise subscription for experimenting, and inside of it there's a few resource groups. So the tool, we can create a list of imports through a wizard. So if we go to the import wizard, let's say we're going to start from scratch, and it's going to use the CLI to enumerate everything from all the subscriptions that I have active, which is right now just 1. And it's prompting for which resource groups to import. So let's say I want to do everything but the network watcher. This is using the fuzzy finder tool for this interface. So I can select multiple, and then when I hit enter, it will add that to a list of things to import. So if we say list imports, then it shows all of these files. And if we look at it, it's just a bunch of import blocks. So standard Terraform code, but the process of using the CLI to write all these import blocks is what has happened. And then the next step is we want to perform the import. So using the Terraform plan with the generate config out command, it will take these imports and it will write the HCL for us for each of these resources. So it's going into Azure using the normal Terraform code. This is just automated the process of writing the import blocks and creating the interface for us to pick from them. And the generate config out command usually does have errors. So if you generate the config for a role assignment, it will include the role definition name and the role definition ID, which is a conflict. So if you run Terraform validate after doing that, you will get some errors.
And this is very true. And actually Terraform has this feature built into it where when you do a Terraform import, like you can actually pass it a parameter. It's quite a long parameter where it will output the Terraform code into a TF file. I wouldn't recommend this approach. I cover this in my book a bit, Mastering Terraform. think it's chapter 16 or something. But when working with existing environments, right? So the age-old question of do you import it or like through some automation tool and then refactor the yuck that comes out, or do you take a little bit more of a scalpel type of approach and really fine-tune things and slowly basically reverse engineer the environment? So this reminds me a lot of the Azure Terraform export tool, which Stephen Ma and Mark Gray have within their purview. And it just like the difference is, it seems like this is the way that Dominic has structured this. It feels a little bit more like what were those old games? They're like text ASCII based, role playing games. Where it's an interactive command prompt kind of experience. It's a little bit different than the experience with the Azure Terraform export tool, which is a little bit more command line driven. The Azure export tool does have some interactive stuff, but it feels more like a command line tool where you can add the parameters to drive the outputs. I don't know if I like the approach of just like picking resource groups. I feel like there should probably be a better way, of kind of scooping the resources, because that's essentially what he's doing here. Is he's using this interactive tool to basically go pick from within his Azure context resources. In this case, resources that live within resource groups that he adds to some list, and then just says, "Hey, we're gonna bring all these resource groups together." Right. This is part of a process where if you are going to be doing if you are going to be bringing an existing environment under management, then you're going to have to be thinking about where those resources are going to live from in the code, but then also where they're going to live in a Terraform workspace. So the workflow that he's showing here is a little bit foreign to me. It's not a workflow that I follow or have followed in the past when I've been doing this type of work, because usually I do a little bit more planning on paper, like in code, like, or in like a diagram of like where I want things to go, what module things are going to go into. And then I kind of skeleton or stub that out before I start that like import process. Whereas this kind of feels like that text-based ASCII game, right, from the 80s or something like that, where, or choose your own adventure, where it's like, oh, there's do you want to, you came to a fork in the road. Do you want to go left or do you want to go right? Oh, there's a monster if you go right. Or if you go left, oh, now there's a stone door. Should you open the door or not? It's kind of that feel. Whereas the workflow that I've typically followed is, I'll go out, analyze the existing environments, tag the resources, that I want to bring into the particular workspace or root module, and then using a tool like Azure Terraformer, and then using a tool like Terraformer, which, not to be confused with this channel, but like it's an open source project. I think Google maintains it, or the Azure export tool for Terraform, and basically scoop those resources out of Azure and generate the import blocks and generate the code, and then it's a big refactoring exercise. So this is a little bit of a different approach, using that interactive command. So I don't know. What do you think about that? Do you like the idea of like using kind of a command line, interactive command line as a discovery tool to go find the existing environments that you want to pull into Terraform code? Would you only do it by resource group, or would you need finer grain control when you're importing your resources? Let me know in the comment section below. I'd be curious to know more.
So import encountered problems. This may be because the generated code needs attention or it could have failed. So then the next step is we have this code, which is, I don't know if I have a command to jump to it, but there's a second step, which is processing that code to something more like what a human would have written. So if we run this process step, it will do a bunch of cleaning up, and now we can jump to blocks. So let's say I want to look at this one. So it'll jump into VS Code. So we have the providers that have been written out. So if you have resource groups in different subscriptions, it will have.
So it looks like his code generator tool does something similar to the Terraform command line itself, and it dumps it into a single TF file. And then from this point, refactoring would commence, right? Like you're going to go and you're going to, I guess, like split up the TF files, you know, to follow your traditional conventions in terms of how you organize your modules. And then you're going to have to go through and identify where all these invalid attributes are set. Basically, read-only attributes that the code gen like put in there by default because it's a dum-dum, right? And you got to go clean all that up. And then you might have to extract some of the hard-coded values out using string interpolation, and then figure out, do you want to use a local variable? Do you want it as an input variable, etc.? So that whole refactoring process has to commence from this point on.
Created a different provider with an alias corresponding to the name. And now if we look at the resource groups, we have the import block above the resource block, and then the resource block has names corresponding to the resource group, and then followed by the subscription, just so that it's guaranteed to be unique. And it has the standard code that's been outputted. And in this case, the tag.
Now, I don't know. I've never tried to put a GUID. I guess it would be okay because it's using hyphens and underscores as special characters. But that, like, I'm not a huge fan of how those object references are being set. Like you can see on line 21, every Terraform block, there's the block type, which is resource, the resource type string, which is Azure RM resource group, and then the object reference. This is the essentially the variable name that this particular resource block will be referenced, you know, anywhere within this module, within the scope of this module by other blocks, right? So as you can imagine, having, you know, GUIDs in there is not going to be great, you know, from a programming experience, you know, in order to reference this thing in other places. Now, I think I see. I mean, it's pretty clear what he did here, right? Like his code generator can only do so much. It's code generator, so that happened to be the name of the resource group itself. Actually, like it looks like he took the name of the resource group and then concatenated the subscription ID on there, right? So this of course could be improved, right? I mean, instead of using the GUID, you could create like a logical sub 1, sub 2. I didn't point that out earlier, but he newed up 2 provider blocks, one default provider for Azure RM, and then one with an alias, right? So again, that would be kind of an interesting scenario in terms of importation. I don't know if I would want to import multiple subscriptions, you know, into the same root module. I would probably want to have, typically my modules are designed to be deployed to a single subscription, right? It's absolutely an edge case where you are actually deploying across multiple subscriptions in Azure. So this multi-provider block scenario should look a little strange for Azure Terraformer eyes. I have covered a scenario on my channel, one of my Code Ninja code reviews, where this does come up, and commonly it comes up with shared infrastructure that spans an organization, which is most often the network, right? So a hub and spoke network would very often need to span multiple subscriptions. So it's not like this never happens, but it is a bit weird. Just wanted to point that out there.
Resource group included a value that was JSON, like it appeared like JSON. So the processing step converted that to a JSON encode statement instead of just leaving it as a raw string. So this is useful for things like role definitions, where there's a bunch of JSON, or just anything else where it's going through every string literal in the output and doing this conversion. It's not specific for tags.
This is a bit of a nitpick, but this brings up a question in my mind. How many of you guys are using JSON inside of the value of a tag? Raise your hands, or throw something in the comments below. I find this rather strange. Maybe it happens. If so, let me know what the use cases are. I'm all ears. But I get what he's saying here. Like, he's not advocating like thou shalt put JSON blobs into tags. He's using it as an example that his kind of post-processing of the code is doing a bit of a cleanup, and one of the things that it's doing is JSON encoding, which is fine. And he says that it does that anywhere he detects what looks to be like a JSON blob, which is cool. It just kind of sparked in my brain, is this a thing? Are people putting JSON blobs in tags? Why would one do that? It seems like that would make it more difficult to process. I mean, maybe if you're automating the attribution of tags, and then you have a system that's scanning those tags, right? Maybe that would be what you're doing. But I typically have only seen primitive strings in tags. Let me know in the comments below. I'm curious how prolific this use case is in the field.
So this has, I think in this example, I just have a bunch of resource groups, but that is the general process. So this also has support for security groups, which I just didn't set up for this demo. But if you have a security group, it will clean up the user list. So instead of being a list of hard-coded GUIDs, there's also it creates a local block and then looks them up by the email, so that when you look at the HCL that's generated, you know what the email is of the user instead of just having to guess what the GUID is. So that's the first step. And
that's pretty nice. I mean, you're definitely not going to get that out of the box from Terraform generated code, like using Terraform import block to generate code. Things like that, that's often what the refactoring work is doing, is like using your human intelligence to be like, if I'm going to maintain this code long term, humans are going to be doing that, right? So humans don't like looking at GUIDs, right? I don't look at a GUID. What is this? Do we have a GUID here? I don't like looking at GUID Delta 4287881 and be like, oh, that's Bob from accounting. Nobody does that, right? And I think I even have a video where I talk about this. When you're maintaining infrastructure as code, you should declare war on GUIDs, right? Try and minimize the footprint that GUIDs have within your code base. I know Azure is the most sophisticated GUID generator on the planet, but from an infrastructure as code standpoint, that's not helpful to a human author, right? So try and take advantage of data sources that Terraform has, and it's really cool that his code generator is smart enough. And I'm curious if I would imagine he has to implement each of these cases. Like, from his knowledge, he's like, oh, I know that when this resource emits code, it's going to be a common use case where it's going to spit back a GUID. Like, the common attributes are going to be principal ID, right? Anytime you get a principal ID, that's probably going to be a pointer at some Entra ID entity, whether it's a managed ID, whether it's an Entra user or an Entra group or something like that. It's going to map to something over an Entra. So there's probably a small number of cases, like different attributes that you could pick out in order to implement this kind of code gen. So that's really cool. And I don't know. I don't actually know if this is built into Azure export tool for Terraform. I think when I was using it, it wasn't. So I think these are great ideas, and I think some of these ideas we should just fuse into the Azure Terraform tool for export, and maybe just recruit Dominic and be like, hey man, let's work on this one tool. I know Dominic's making his own tool, but maybe we can combine forces, right? And make one tool that's awesome.
There's a few other automations in this tool. So you can activate PIM rules from this, where it'll use the AZ REST command to enumerate them and then have you pick. But in my test scenario, I don't have any of them. But it's just trying to be a few quality of life things. And then there's also a browse resource group. So it just gives you a quick interface. Let's say I want to know what my resource groups are, then I can search for it using the fuzzy finder, which is very useful. And then I forget what it does when you enter it. I think it just shows the ID for you to copy. But then the second part is once we have this information, we want to visualize it. If we run that, then it will look at these files and it will interpret the HCL and try and create something that's a little interactive for us to look at.
Now, there are many Terraform visualizers out there on the planet. So I think I admire the passion of Dominic, but in some ways, I wonder if he's like taking on too much scope here, all by himself. But I think just the work that he's done from a code gen standpoint is huge, right? So it would be nice if we could like take what he's done with the code gen and then just mash that up with a Terraform code visualizer, and put them together like little Lego bricks, right? That would be cool. I don't think Microsoft has like our own Terraform visualizer. The ones that I'm familiar with are like Brainboard and Structura.io and stuff like that. But maybe those are kind of tied to a commercial offering, and they aren't easily pluggable into an open source tool like this, right?
So if we look at this here.
What is that? What is that? WPF? Is this like, I mean, it's been a while since I've done Windows dev, but the generic icon app kind of looks like a WPF app. I mean, it's pretty cool. Like, it looks like he's got some sort of like physics engine running on these things to make them jiggle or whatever.
We have, it's obviously still a work in progress, but we have the subscription with all the resource groups in it. And then it has noticed that there's the resource block inside of Terraform or inside the HCL code. So it knows the name of that block. It has the icon because it knows it's a resource group, and then it knows where that HCL file lives. And this is using just a config file to tell it where to look for the HCL files. But the idea is that you would be able to visualize your tenants and say, okay, I have all these resource groups, but where is this actually being managed by infrastructure as code? So, okay, there's a file here.
I want this on Azure. I want this in the Azure portal. Why isn't this in the Azure portal like today? I mean, this would be an amazing feature. If we could, first of all, like visualize a landscape like this and be able to slice and dice it using tags and resource groups. But then be able to tie those resources that are out in your existing Azure environments back to the code that manages them. That would be huge. I think I bring up this point, on the call in a little bit, but I've been thinking about this since the call, and this would be such a great feature and such an innovative feature, if we did it. I don't know if we're working on anything like this, but that would be so sick, just from like an infrastructure as code practitioner or operator perspective, because there's absolutely kind of a void or a chasm between the GitHub repo and the code world, the state file, and then what's out in Azure.
Here, and if I hit E on it, it jumps me to that definition where it's being imported and where it's being declared. So the idea is to try and power high-level overviews and make it so that you can fearlessly perform code modifications without limiting yourself to HCL. So if you have people who want to use the portal, then being able to transform everything in Azure into code and letting people make the modifications. So if they want to use the portal or if they want to use Bicep or any other series of tools, then being able to convert it to a standard representation that you can then do discovery through is kind of the vague goal. I have a PowerPoint document.
It almost sounds like what he's proposing is that we need to have a bidirectional, code provision stuff to Azure, ClickOps engineer, portal jockey, goes out into the portal and bounces around with their little mouse and clicks around everywhere, creates drift, and then it almost sounds like he's imagining, okay, that drift we want to bring down into the code. We should just leave the import blocks and re-import the drift that happened out there in Azure. Kind of a radical idea. frankly, I've always viewed the import blocks, the remove blocks, the move blocks, these refactoring blocks as temporary additions to your code base, to perform the action and then clean up afterwards. But I mean, what he's proposing is, technically that import block could possibly act as almost like an umbilical cord to that thing out in Azure, and allow you to kind of continue to re-import that. However, I worry about that. Once it's in the state file, let's think about this, right? Because once it's in the state file, the import block is about getting that resource that's out in Azure, that's not under Terraform management, into the state file so that Terraform is now managing it, right? But as soon as that resource is brought into the state file, then that import block is meaningless, essentially, which is why you typically clean up after yourself, delete the import block, and move on with life. Because now that resource is in the state file, then the umbilical cord is there, right? Terraform knows that thing's out there. It's in the state file. You can go do it again. The only reason why you would need to ever re-import that is if you didn't maintain a state file at all, which I suppose one could do that. Let's say you just ran Terraform and didn't maintain the state. Let's say you set up an Azure DevOps managed pool, right? And you did not create a backend, and you're running a local Terraform state backend every time you run Terraform apply, and every time your pipeline executes Terraform, it goes and re-imports all that stuff. This sounds like not a great idea. Just saying. So I wouldn't encourage this. So because what that's going to lead into, first of all, I don't know how much. It seems like there will be a lot of churn every time you do an import, right? Because as we've seen, there's a potential for there to be kind of disjointedness between what's out there, and it may not always be a smooth update to the code. That would be an unnatural path for how to use Terraform. Interesting, unique, clever, but I think you would be kind of like swimming upstream, so to speak. Like you're doing a whole lot of work, and you're not really using the tool the way it was intended to be used. And for what benefit? For what gain? Right? So, and frankly, typically the way that the drift resolution workflow operates is that you import the resource that was managed previously. It's in state now. Okay, you detect where there are like changes in code that you need to clean up, and then you run apply. Okay, now that thing's in your code. Now that thing's in the state, and it's 100% accurate with what's out in production. Right now, drift happens. Some portal jockey goes running around in the portal. They stomp on your rose garden. They change some things. And let's say you go and be like, hey, Bill, I saw you were in the portal and you stomped on my rose garden. And Bill's like, yeah, I had a really good reason why I did that. And you're like, oh, really? Okay. Well, let's just update the code to reflect, the changes that you made, right? You wouldn't import the changes that he made. You would run plan and you would analyze the deltas, right? That's what Terraform does. It tells you what's different. And then you would say, okay, Bill, I see this thing changed and that thing changed. Were these all intended by you, right? And Bill's like, yeah, I meant to do that. I meant to do that. I didn't really mean to do that, but so you could revert that if you wanted, or whatever, right? There's a process by which you kind of rationalize, what changes, what drift you want to keep, or what drift you want to revert, right? And there's human intelligence that is applied to this process to make sure that the environment is stable, the code base is brought up to reflect what the intention is for the operators, like how do you want to maintain that, and also to bring Bill into the fold, so that rather than going out and portal jockeying it into the resources out in production or wherever, like Bill will be like, oh, okay, I see that this is the place in the code that I need to go update, and I shouldn't just go out to the portal and just like stomp on your rose garden, right? Next time I'll just go make the change here. There we go, right? And then the workflow, is more in line with infrastructure as code workflow, where okay, we make the change in code, we test it with Terraform plan, maybe we apply it to an environment to verify, that the change is what we want it to do and it works smoothly, and then we shepherd that to production, right? But I'm not a fan of this like idea of like re-importing drift automatically, right? Without having that conversation, or just opting out of Terraform state altogether. That sounds a little bit scary. I don't know if that's what Dominic's saying here. Maybe we'll hear more.
There's a few slides. I don't know if anyone else has anything they want to get into, but I can keep going on this if that sounds good.
Thanks, Dominic. I know last time I said we should definitely have you on next time and talk about stuff. And then I completely got swallowed up with a million things and never reached out to you. So thank you for coming back, for talking. I do want to let Mark T ask his question, though.
Yeah, go for it.
No, I great work, man. This looks amazing. I think one thing that stands out to me, and this is kind of a problematic thing as an operator, where we have the Azure portal and we have Terraform, and there's kind of this like divide between the two planets, so to speak. We always have to do this mapping between like, okay, once we spit stuff out into the Azure portal, we have to know where the Terraform state file is and where all that stuff lives. It's kind of, I don't know if that's the direction you're going, but I think that would be really cool if we had, maybe it can't be canonically supported in the Azure portal yet, unless we wrangle a few PMs to include support for that. But if by convention we as a community came up with a method to add traceability or discoverability for, okay, hey, this is maybe through tagging, but like, hey, this is a resource and here's where you might be able to find the state file that manages this thing. And then like, where is the source code as well, right? That traceability would be really cool. I don't know if it seems like that's the direction you're heading. That's a really great idea. That's a really great point that I make to myself. This is really weird. Like I'm observing a call that I participated in, but no, like why doesn't this exist today? Am I right? This would be so cool. Like I'm just envisioning like in the Azure portal, there's this like slice, on that side, on the menu bar, sidebar, right? For every resource group, that's like a pointer back to a GitHub or an Azure DevOps, repo, right? That like would directly link you to the code block where that provisions this resource. How sick would that be? That would be amazing. Oh my gosh, I'm getting excited. I'm getting a little excited, but like there would be a lot of engineering to make that possible. But that could absolutely be possible. You would have to capture metadata about the source code repositories. There would probably have to be some sort of like rich handshake and data sharing between the source code management platform, GitHub, Azure DevOps. I mean, like Microsoft owns a couple of those, right? Like so, it's not outside the realm a possibility that we could do this. But I mean, just imagine like if you had full traceability from the portal, so that your operators would know immediately if this thing was managed by infrastructure as code or not, right? And then what flavor of infrastructure as code is managing this? Like, heck, like let's open this up beyond Terraform, like Bicep, ARM, Pulme, like whatever, right? If we as a platform provided hooks, right, for infrastructure as code tools to hydrate that kind of context, right, and then expose that in a uniform way through the portal, that would unlock new productivity, improvements for operators, right, for DevOps teams. So that would, like, man, I can't wait for HashiConf to like spitball this stuff with Stephen Ma and Mark Gray a little bit more. But like, if you like that idea, you know, give this video a thumbs up, throw some comments down in the comments section below, and let Mark Gray and Stephen Ma know, because you know, I think this would be really good capability for both Terraform and Bicep, and you know, who knows, whatever infrastructure as code tool. If we build that interface to hydrate that and to present it within the portal, you know, maybe it's just a fancy tagging scheme, right? That the portal picks up on and like recognize it. I'd prefer it to be a special place, right? Because I don't think infrastructure as code is going anywhere. It would be nice if there was like a special payload that you could hydrate this data. That way we're not like reliant on the brittleness of just magic strings and tags, you know, but this would be a really cool thing.
The discovery, I did some considerations like, well, we could use tags for it, but then you have to make sure that the tags are up to date. And I think the core loopback mechanism, when you have,
well, and it doesn't matter. Like you're gonna keep the tags up to date, right? So, but again, like let's not use tags. I agree. Let's not use tags. If ARM, the control plane, for every resource that's provisioned to Azure, provided some metadata that like would point back to where the source code is, literally git repo, code file, line number, right? You could get such precision to like jump back directly to the code that provisions this thing, right? You could even build in drift detection into this portal experience to be like, oh yeah, you know what? This is managed by code, but you know, when I did some code analysis between the code and what's actually provisioned, there's actually drift. How sick would that be, right? And I think I'm going to get into this later with Dominic about, you know, having some sort of drift detection Azure policy kind of thing where you know, it scans the resources within Azure and shows like drift, which is a little bit different. What I'm talking about here is traceability from the provisioned resource in Azure to the actual code block that manages it. The other topic is kind of this proactive drift detection scanning mechanism to follow those little threads to all the different platforms, right? All the different code infrastructures, code mechanisms, and be able to tell some enterprise governance person like, hey, across all of your resources in Azure, let's say 70% of them are managed by infrastructure as code. And let's say of that set, let's say 89% of them are up to date, but we got 11% of these resources that have drift. And then that gives you, just like Azure policy, kind of a punch list to go through and be like, hey, team A, you know, here's your drift, go fix it. Team B, here's your drift, go fix it, right? And eventually these teams, just like with Azure policy, will become self-managing, where they can manage their own drift and Azure can help them do that. And of course, we could plug into other platforms like Terraform Cloud, you know, to facilitate that even further.
Have an import block in your code, then that means that you can run the code without having a state file, because it'll just all zip together, and maybe you'll be forced to store stuff like passwords inside a key vault so that they can be retrieved without having them hard coded in your code as plain text, because that's obviously.
Wait. Did he just say provision with Terraform without a state file? That's what I was worried he was going down with, like these, like leaving these pervasive import blocks in there. Again, I don't think that's a good idea. You need to. Terraform state is designed to be that umbilical cord between the resources in code and the resources that are provisioned to the cloud. I think trying to replace that with the import block would be a bit of a bastardization of that design.
Not good. But when you have a resource group in Azure and then you have an import block, you can do a lookup and say, well, what import blocks have the ID that corresponds to that resource group, and what resources do those import blocks point to? So doing that, the challenge then becomes, well, where is the code? And that's usually a Git repo somewhere. So that could be Azure DevOps or GitHub, both of which have tooling to enumerate. So if you clone every repo in the organization and then look at every HCL file for all the import blocks, then you can do discovery without necessarily requiring tags. But of course, tags would help you get to that location faster. So if you indexed the resource group.
Okay, I see what he's saying. He's taking a little bit of an opposite approach of what I said. Of course, if this would what he's saying would be a potential solution if you didn't have that metadata built into the Azure control plane, right? If Azure didn't support this, which it doesn't today, just to be real clear, what I'm proposing is like Azure to support this, right? But let's hypothetically, if Azure were to support this, right, then what he's describing wouldn't be required. Like you wouldn't have to go through this like weird. You wouldn't need some other mechanism to maintain the connective tissue between the code and what's out in your actual cloud environment. And you wouldn't have to scan code to do that. Terraform State does that for Terraform. Bicep, uses the Azure control plane itself. Of course, I have had way too many situations where Bicep gets confused, and like it's almost like Terraform in a situation where Terraform like lost its state file, and Bicep is like, I'm trying to provision an entire new environment, and I don't even realize that this environment's already been provisioned, which is pretty frustrating. So if you've used Bicep and if you run into that, I'd love to hear you down in the comment section below.
And said like, okay, it has a tag that tells you what repo to look in, then that would help avoiding having to clone every repo in the org. But there is a lot of room for automated discovery and saying, well, as a cloud admin who does have authority over every resource group, even though we've delegated some of that to clients, I can still see the repos and create this lookup on my own and see what's being managed where and identify gaps. So if a client has somehow made it to prod without creating any infrastructure as code files, then that could raise some warnings as well. So there's not, I don't have any of that working, so that is like cloning the repos and scanning through it, but I have this part working where it knows that we have an HCL file with a definition and a resource group in Azure that corresponds to that definition. So this is the proof of concept that is working, and then scaling that up is one area for future work. So the config file for this is...
Yeah, and I guess, Dominic, what I'm trying to say is I don't think that should be your responsibility to do. I think that should be the responsibility of the cloud platform, that the cloud platform that wants to support infrastructure as code developers as first-class citizens. I would hope all cloud platforms would want to do that, right? They should provide a mechanism for traceability so that those developers don't have to go come up with their own thing, right? This should be built into the control plane for public clouds like Azure, AWS, GCP, so that it becomes very clear what's under infrastructure as code management and what's not. And you could design that interface such that it's totally optional, and third-party infrastructure as code tools can interface with it if they so choose, just like first-party infrastructure as code tools would, of course, naturally integrate with it, like CloudFormation on AWS, or Bicep and ARM on Azure, and then third parties like Terraform or PullMe, they could opt into that if they wanted to. They could take it. I don't know why you wouldn't want to take advantage of that, because it would help, your people that are using your technology to manage their environments in production.
Somewhere, let's try this. Yeah, so this is the config file. So the directories that it's scanning is just a path, and this is an array that you can add entries to. So that would add more entries to be observed for this graph generation. So if you have 6 different repositories cloned, then you would just be able to add it to this list, and I think there's even a subcommand to help with that. And it also has support for switching between Tofu and Terraform. So when you're doing the creating the import blocks and running the Terraform plan out, then it can switch between them as well.
What call does he think he's on? Anyways, I understand his tool is doing code scanning. It's designed to be used like as a local developer. Where I was going was like, I love the concept and that he's touching on here, which is that traceability and discoverability, that connective tissue between the resource provisioned out to the cloud, the state file that maintains, that the current state of that thing as provisioned from the last known good state, and then the source code that is used to maintain the configuration as that captures the intent of the developer. I guess what I'm saying is I think it would be really cool if we had a solution like Azure Policy, but for infrastructure as code, that would scan an Azure tenant, that would scan management groups and all the subscriptions and produce a list of drift that was taking place. And that could be done using this rich set of metadata and OAuth handshakes with the version control systems like GitHub and Azure DevOps and all of them out there. Third-party ones, as well could be integrated and probably are already integrated, to allow this scanning tool to go look at the infrastructure as code metadata for each resource, find the corresponding code block that defines it, and then do an evaluation to detect drift and report that through the Azure portal in an Azure Policy kind of infrastructure as code lens. That's what I'm saying. And that I think that's the natural place for a tool like this to sit at the control plane layer, not stuck on an individual developer's workstation, because of course, that would encourage people to have kind of God mode, right? Where you have access to all the Azure subscriptions, all the Azure management groups, all the source code repositories, right? In a large enterprise or even, organizations of different sizes, that's not a good idea, right? So that's why Azure Policy was architected and Security Center was architected the way that it was, to allow for kind of this overarching detection system, but then to allow enterprise organizations to decide who should have access to what. Yeah, it sounds like something that if it were running, something that could be embedded ideally like in a GitHub enterprise type environment, maybe as a GitHub application that would then, because who has access to every repo in an org, right? So,
Sure.
But like if there was some system like that was like, how would an organization scale this, right? Like unless we built this into GitHub Enterprise or into Azure DevOps or something like that, or into the Azure portal. I don't think the Azure portal would be the right place, because then you'd have all this tight coupling with the source code repos. I actually talked myself out of that position, because thinking more through, having that metadata to describe, where the resources managed in infrastructure as code makes a lot of sense. And if there was something like, there is a precedent set for Azure Policy and for Security Center, right, to have kind of extensions and Arc, right, to have extensions outside of Azure. So this infrastructure as code engine, right, drift engine, could tap into this metadata that's provided in order to do that scan at that tenant level. So I kind of, after reflective thought, I've changed my tune a little bit. It's definitely an interesting train of thought. Like, how can we make traceability from the code, to what's in production? I think the same problem would apply for Bicep as well, right? It's not a Terraform unique thing. Terraform has the additional intermediate, step of the Terraform state, which Bicep does not have. But I think it is a common problem for Bicep and Terraform.
So I think all the vendors have been doing a great job in terms of providing the tooling to make a consumer app like this possible. So Azure has the AZ API where I can say AZ group list and it gives me all of these resource groups.
Yeah.
There's some nuance to the implementation details of that, where if you have 16 different subscriptions, then the AZ CLI expects you to pass in a subscription and run it 16 different times. So if you use the resource graph, you can query the resource containers thing and get it all at once, which is much faster. And that's another story on the Terraform side, where if you have 1,000 different resources and you run to Terraform apply, it's going to do 1,000 different queries to Azure to make sure, is this one resource in the good state? And then is the next resource in the good state? Where if you queried all the resource groups at once, you get a huge JSON payload, which you can then do some correlation on. So the writing of the imports and doing the earlier step where it's saying like, what resource groups do you want to import? That list of resource groups is queried using the Azure graph instead of some of the other stuff. So trying to be as optimal as we can with trying to create all of these lookups. So when it's getting all these resource groups, it's caching that information. So when I ran it this time, it didn't have to go back to Azure and ask for that info again. So doing the caching story as well is there's a lot of information that isn't changing from the day-to-day, and giving the opportunity to bust the cache if you need to, but also having it not when you don't need to. So maybe when you come back in 7 days, there's an expiry window that is passed, and it will fetch everything again just to make sure that everything's up to date. But when you come back tomorrow, it is not going to have to refetch everything because it's most likely not going to have changed. So trying to be minimizing the time to useful information so that if I want to see all my resource groups and just search for a name because something came up and I want to find out what it's called, then having the fuzzy finder quickly available instead of having to wait 30 seconds to fetch every subscription is pretty useful.
And again, I think Dominic is definitely looking at this through the lens of an individual developer, kind of like a super user, kind of spelunking this themselves. But I would challenge like ourselves, Microsoft internally, like how can we help? How can we take that burden off the shoulders of that super user, that power user, right? So that they don't have to go do this. So they don't have to, as Dominic points out, write those adapters, to query, the Azure, using the Azure CLI or whatever to query the things and do all the things. Like, how can we create a leveraged tool that would do this scanning automatically, and just like Azure Policy, run on a 4-8 hour cycle or something like that, where it can cache all this stuff. It could even respond to merges to main if we have that handshake with the version control system. Like, we could be able to know through an event driven way when the code changes, to like, hey, go check, with check the drift, right, to see if the code is still matching what's in production. Yeah, the Azure kind of reminds me of like what the way Azure Policy or Security Center works, right? Like Azure Policy has this like almost like a circadian rhythm where it executes, I don't know, 4 hours, 8 hours, whatever, but like basically it's going out and scanning all the things, right? It would, like, if we built something like almost like that, but for drift detection, where it would almost empower infrastructure as code developers to identify drift, but then also to import, and kind of bring under management, right? Or like slowly over time, like evolution versus revolution, like how using a capabilities like you're showing here, more at like the developer layer. Like, how do I bring more infrastructure under management over time? How do I know what's under management, what's not under management from like different levels within my organization, management group, subscription, down? I'm kind of spitballing here, but like, if there's like an Azure Policy service like that,
key for drift detection, which is something else that I've mentioned in the PowerPoint. So if it's okay, I'll go through this because I think this has a lot more information that can be branching off points for future discussions.
Yeah, I mean, it's not my quarter, but yeah, I mean, Stephen, like Mark.
And of course, this is all open source as well. I pasted the link in the chat there. So I think I will try and breeze through this just to be respectful of everyone's time, but also try and get some ideas floating out there. So the idea is bidirectional Terraform. So infrastructure is code without precluding click ops. So if you need to add 100 users to a security group, then that's something that's kind of easily done through text, where if you had to click through the portal, that would be a very unhappy afternoon. And then being able to detect and revert unwanted changes, which is a core feature of Terraform, where it will tell you if something is different in the cloud versus your config, and then being able to accelerate healthy transformations through high-level overviews. So if we have a resource group with some tags, then getting the code for that, as we showed, with some kind of snazzy features like converting the JSON to blocks instead of strings is nice, being able to have this automatically converted and organized. So the motivation, IAC helps manage the cloud with fewer mistakes, and why do by hand what can be done automatically? I know I've deployed stuff manually in the past and then said, okay, well, I'll convert this to infrastructure as code later because it's a little easier to use the import blocks and stuff. But that entire process can be automated, and I think that's something worth pursuing. So the general workflow
or just like, if you have the option, don't start from a ClickOps standpoint. Start from infrastructure as code, right? I think that's where we're trying to get people to be. The reality on the ground is a lot of people have a lot of stuff that they ClickOps into production, right, or out there, right, and so they have to find a strategy to bring that under management, importing, or whatever mechanism you use to import, or using a blue-green type strategy to provision a new environment that's under management and then transition to that. There's many different options available to people. But yeah, I think the workflow for Terraform and for infrastructure as code, really, right, should be like what I described earlier, which is, hey, the source code maintains, what's the last best good configuration, and we do drift detection by kind of evaluating what's out there and what's in source code. And if people stomp on our rose gardens, we have to, sit down, analyze like what's changed, what was intended, what was not intended, and then go through that rationalization. I don't think we want to continue to perpetuate or encourage kind of heroic ClickOps, portal jockeying actions. We want to help upskill people so that they, can do that within source code first and start there, rather than, I don't feel comfortable doing it through code, so I'm just going to go ClickOps it, and then we'll go fix it later, right? Now, I'm not saying like there's not a place for discovering and like learning through ClickOps, right? I still do. I do that, right? I think everybody does that. Like if you're learning, how to use a new feature, or you're learning how to provision a new service, you're probably going to do it manually first, maybe the first couple of times, and then you're going to kind of walk back and then automate it, and then you'll delete, the manual stuff that you provisioned, and now you've got the automated way, and you're good to go, right? So, and there's probably always going to be situations where if there's an emergency patch that needs to be done, maybe you still ClickOps it, right? But then you follow this process of, you don't import that. You go modify the code, you run a plan. Okay, yep, code matches production, we're good to go. I don't know if I'm fully on board with this whole bi-directional, let's embrace ClickOps kind of like the way that it's being presented. But
you have the Azure portal, and then there's the CLI, which gives us JSON, which we can convert to some programmatic representation, which we then write some import blocks, generate the config out, which gives us more HCL, which we can then parse and do some prettifying, and then commit to a Git repo, which is then ran through a pipeline, which can then write back to Azure. So it's...
I'm all for that. Like what he just described is like the import process, right? Import, generate, refactor, run Terraform, apply again. That's fine. That's absolutely a viable scenario. And I hope I'm not misunderstanding Dominic, but like it seems like like what he's imagining after that step is that like we'll continue to re-import the ClickOps yuck. you know, that's the thing that I'm not on board with. But all this is fine.
A little bit of a circular loop here. And then there's pipelines. So if you have the capability to generate HCL that describes your entire tenant, and you do that today and tomorrow, you can do a diff and see what has changed over time. And if
So blast radius. I mean, I don't think it's advisable for everybody to generate code describing their entire tenant. I'm not sure if Dominic's like saying this more as like as a utility for creating global drift detection. Maybe that's what he's saying. And in parallel to that, people still have individual like deployments for their applications or their services that they deploy. But I've built many Terraform modules that are way too chubby. I mean, we've all been there, right? Like, because you're like, oh my gosh, this Terraform's amazing. Like, I can do everything, and then you put everything into one Terraform root module, and then it like takes 2 hours to apply. It's like, it's just like slows down to molasses. Like, imagine doing this across an entire Azure tenant. That like I'm using my words very carefully here. Tenant, right? So that's every management group, every subscription in every management group. That's what we mean when we say a tenant. That could be thousands, hundreds of thousands of resources, right? In one Terraform state file. Even if you're not going to keep the state file and do as Dominic suggests, like you're going to you're going to throw away that state file and regurgitate, like not a great, like you're not going to maintain that IAC code base for your entire tenant. It's you gotta refine the blast radius, and unless even if your company is a small, and I started a company, a health tech company, and so I'm familiar with the startup space as well, right? So even if you're a small company, you're not going to want to have everything that your whole company provisions from an IT infrastructure standpoint in one Terraform root module. Like, no way. And then and of course, most of my career I've been in enterprise, right? Forget about it. Like in the enterprise, like there's so it's huge, right? The landscape is just huge. Like it's not feasible.
You have code in the repo from yesterday, and then you run the pipeline again today, it's going to attempt to clobber and revert those changes. So using pipeline approval mechanisms, you can have two different things happen. Is either you proceed to the apply and you revert an unwanted change, or that change alert tells you that your infrastructure's code is out of date and something has changed in the portal that you want to persist through time. So you would then update your code. And
what he just described there is what thousands of teams do on a daily basis, managing their environments using Terraform or infrastructure as code, using pipeline tools, right? Like you have a planned pipeline, you detect drift through the planned pipeline, you resolve it, then you run apply, right? So that's all fine. It's just about the scope of that, like how much scope is going to be within that root module. And what he was proposing was just way too much scope.
So the process of generating code is you generate all the code for the existing infrastructure, and then something has changed manually in the portal, and now the code is drifted. So there's drift detection that needs to happen. So running Terraform apply will suggest reverting all those changes. So we need some kind of tooling to work for the diff resolution. And ideally, it'd be one click. So if someone's made a change and we know how to codify everything in the portal, then we should be able to, with a single click, integrate that change back into our code base.
I mean, I like this idea. And I think ultimately that's where I would like to see us get to with this whole metadata about and traceability down into the exact block that is provisioning a particular resource out into Azure. And if we jam AI into there, like we could probably get into a place where like we could automatically generate or update the code to bring in the intentional drift, or the drift that we want to keep, right? But it is a bit of a foot gun. Like, you got to be careful, right? Because if you don't apply human intelligence, right, and to drift, then there could be unintended consequences, right? So I think part of infrastructure as code and operating with infrastructure as code is recognizing your responsibility as an operator, as a good steward of this production system. Like, you have to be careful, right? Like, we can't just automatically bring in these changes without thought, without testing, to verify, that there's no downstream impact to our environments.
If you are generating everything every day, then you're kind of doing a diff from the old code and the new code, where the new code is always an accurate representation of what exists. But if you have...
I don't see how you could do that, generate the new code every single day. Because until we get into a place where the code generation is just so 100% rock solid and predictable and accurate, right, that we can rely on the code that gets emitted, then we could generate the code every single day. But then, like, what's the point? Like, if you're generating the code every single day about what people click ops into production, you're not really applying software development lifecycle to your infrastructure. You're just, like, generating code. What? Just to generate code? Like, does it make us feel good that we have, like, the code for it? If we're not going to use the code long term to manage the environment, what's the point of generating the code? I guess I'm not quite following that.
Some golden code that you, over time, instead of just always accepting the new code, you're kind of keeping some older code up to date. So there's what you want, what your code says, and then what actually exists are all integrated interests. So the resolution tooling, so if you have a security group and then there's a new member or removed member, then there should be some kind of interface where you just say, yep, I want to keep that change, or no, I want to undo that change. So the expansion of that is something that could be listified, where it's just a little 3-mode checkbox where, kind of like the Terraform output, shows you what the plan is to approve or deny each of those individual changes.
And what he's showing here, I think is a great idea. But I think it should be done in the right way to implement this functionality would be in the Azure portal, right? To show, or some third-party tool, right? Maybe Terraform Cloud does this, right? Or will do this someday, right? But I don't see why cloud platforms couldn't do this themselves. But I like the idea. I just think I would take a different implementation approach.
Of course, Point has a lovely animation with this page possible. So I mentioned earlier the user IDs. So when you generate the code for a security group, you get the hard-coded object IDs. And I've annotated them with some emails here. But if you had to update this list, there's no guarantee that these comments are accurate. So one possible approach is using data blocks. So if you have a contributors group, then there's members and owners, and you could use a different data block for each of the member and owners. And that would let you use the emails, which is a bit more natural for human consumption. And the other way that you can do it is you have one data block that contains all the emails, and using a local block, you turn that into a dictionary so that when you are declaring the members and the owners, you reference the same local block using the emails. And that is an easy way for 16 different security groups, you just have one local block and you're referencing the emails for the users.
Yeah, I don't know. I don't know, man. Like, I guess what he's trying to achieve is he's trying to reduce the number of data source operations, because essentially what happens is, let's say like Lillian, right, at contoso.com is actually in both the members and the owners, right? Then if we were to iterate across the owners and the members using two different data sources, we're going to make two requests, right? So this to me seems like a micro optimization, and actually like the right-hand side. The right-hand side code looks like a micro optimization and actually yields more difficult to read code. So I would prefer like the left side, of course, not with all the GUIDs, right? I think I did a video exactly on this subject, right? Where basically I'm telling people don't do the top of the left, right? Which is like, hey, Lillian is GUID 7 Foxtrot Alpha 1 Charlie, right? Like that's Lillian. No, nobody knows that, right? Use data sources. That way you can use human readable configuration elements, like an email. That's pretty easy to tell. But I feel like the right, I see where he's going with this, right? He's trying to reduce how many data source calls that we make to the control plane. But to me, that's just unnecessary. And I mean, you can clearly tell the cyclomatic complexity of the code on the right is more complex than the code on the left, just from a cyclomatic complexity and like a human readability standpoint, right? It's just like, what is going on? Like rows 51 through 53, right? I mean, it's a little bit nutty.
So this was just me brainstorming what exactly would we be trying to codify? So there's management groups and then resource groups and subscriptions and security groups and roles and role definitions and rules. Interestingly, there's further stuff like PIM. There's even things that say like how long can this role be activated, or can this be a permanent eligibility assignment? And then there's policies. So there's a lot of different concerns here. So basically everything that can be terraformed is integrated, but what are the things to focus on? And then Azure DevOps itself has a Terraform provider.
One of my favorite Terraform providers at that. I have a series on Automate the Automation with Azure DevOps, and I show you how to use the Azure DevOps Terraform provider.
Trace what is everything else touching. So if you have a bunch of app registrations, then those have been created through stuff like creating service connections in Azure DevOps, and some of those service connections may have been deleted. Now the app registrations are dangling. So if you have an interface that shows you what sections are using what app registrations, and then what app registrations have no ties to anything else in your infrastructure, then that can help identify things to be cleaned up later. So and discovery, in an ideal world, 100% coverage. So same thing as code coverage, where people say 100%, but that's maybe really the best. But being able to look at a resource and being able to jump to the definition, whether that definition is something that was auto-generated yesterday in a pipeline or is a lovingly handcrafted file, just being able to jump to that definition is a important capability.
I mean, ultimately, we want to get to a place where where all of our infrastructure as code is lovingly handcrafted. Of course, there might be an intermediate step where we import. And I think that might be where Dominic and I have different points of views on that.
And being able to automate frequent requests. So if you have automated the process of modifying the cloud through code changes, and user requests are requests to modify the cloud, then those requests can be converted to code changes. So if someone wants
there's a startup company that does this exact scenario. I think they're called Abby, and they were at HashiConf last year. And they were kind of showing me their demo, but generally the idea is this: it's like we should use source code as kind of a audit log, so to speak, for granting access or removing access to stuff, right? So that's the scenario that Dominic's talking through right now. There's a company out there called Abby. I have a sticker on the back of one of my monitors. Of them. It's like a cat or something. Abby the cat. I don't know. But yeah, they do that. And they're trying to say like, okay, we should take infrastructure as code even further to more like identity management operations, right? So Entra ID administrators, in addition to Azure administrators, should be using source code to manage all the things.
Existing folder that has a group that controls who your custodians are. So the translation of I want this role is add that user to a security group. And if you're onboarding a new project, then maybe you have a structure where each project gets a folder, so you need to create a new folder, and then in that folder there's a new resource group and a new DevOps project. Creating is just more code modification, and then same thing with creating app registrations. So translating user requests into code and being able to have an end-to-end understanding of what is our domain concerns and how does that get represented in our infrastructure as code.
I mean, that chevron in the middle, onboard a new project, this is kind of like what I'm talking about when I'm talking about automate the automation with Terraform, right? The idea of attacking multiple control planes, or automating. When I say attacking, I mean automating multiple control planes simultaneously to create one composite action to be performed. And so he has a great example here, like onboard a new project. You set up stuff in Azure, you set up stuff in Azure DevOps, you need to have a service connection created, you might need to have Entra ID stuff created, you might need to have groups associated, and then like linked to permissions or roles within Azure DevOps. Likewise, like added to role assignments out in Azure. Absolutely. I think there is there is a lot that can be done to automate the automation for these composite solutions or templates that span multiple Terraform providers, which I don't think a lot of people do as much as they really should, which is one of the superpowers of Terraform. Right? I think Bicep recently added support for Entra, which is great, but and hopefully Bicep continues to expand on that extensibility. I haven't actually tried out Bicep with Entra. If you have, let me know in the comments below how it's been going. But yeah, I think it's promising. Of course, we already have Terraform that does that. So the AAD provider, the Entra ID provider, and the Azure RM provider. So, but yeah, absolutely.
So scaffolding. So what is my purpose? You scaffold the project and then you drift away. Oh my gosh. So when you deploy resources for clients that you and then
I just got to point out there's an Open Tofu logo on this slide again. So, so many people often it's like, I almost feel like it's a bait and switch. They're like Terraform and Open Tofu, but I mean, like they're just trying to push Open Tofu. Right. Like it's like a Trojan horse. It's like everybody knows Terraform, but they're like bringing Open Tofu in, even though I don't know if people use it, but they're like, by the way, like you should really be using this, I don't know if that's going on here, but.
So scaffolding. So what is my purpose? You scaffold the project and then you drift away. Oh my gosh. So scaffolding. So what is my purpose? You scaffold the project and then you drift away. Oh my gosh. So when you deploy resources for clients that you then hand off, you might declare a resource group with some tags, and then the client changes those tags, and later you come back 6 months and you're trying to apply some new tag, but your scaffolded project for this client is now 6 different ways out of drift or out of alignment. And
I think what he's talking about here is basically this common pattern where if you don't actively manage your environments using infrastructure as code, and you don't follow that release motion and exercise that muscle, your infrastructure as code is going to atrophy over time because drift is going to pile up. So just don't do that. Just don't do that.
So the two kind of ideas that came to mind was prescriptivism and descriptivism. So saying things should be this way, or this is how it is or was. So when you're scaffolding configs, those are more kind of historical reference artifacts. So it's not something that you're going to be continuously keeping up to date, but they might be something that's useful. So if you have onboard one client and then you have to onboard a different client, you could probably clone the other one and make some changes. Example is I created a resource group and security group for a product.
Predescriptivism, I've never heard that term before. Maybe he coined it. But basically, this is the idea of my source code is reflective of the desired state. Descriptivism appears to be the actual state represents the desired state. I think that's an anti-pattern, personally. When you think of infrastructure as code is trying to achieve prescriptivism, right? The code represents the desired state. We're working within the reality of an environment where sometimes like it's an imperfect world, right? And there are people that have access to stuff out, that they can exercise their will on, to bring the actual environment out of sync with what the actual code is. But infrastructure as code is about prescriptivism, right? It's about the desired state is captured in code, and we want to always maintain, what's deployed out in production with what's in the code, and like rationalizing the harsh reality that humans go out and stomp on rose gardens. I would not advocate for descriptivism as he's presenting here.
The client has made changes. My folder would show changes if I applied that Terraform again. So this is prescriptive. This is how we start new projects. Whereas if I have derived configs, so I've taken a snapshot, there's a daily pipeline that exports everything as HCL.
Don't do that. Don't create a daily pipeline that exports HCL. I would argue that is an anti-pattern, right? The point of importing code into HCL is, so that you can bring it back under prescriptivism. I'm using this term, right? So that the code represents the desired state. It is not intended to be re-imported every single day. That will just create a lot of work for you.
Changes over time, and using a diff between those snapshots, that is more descriptive. This is a snapshot of the infrastructure. And then the truth, if it's in Azure.
I don't know if that's true. Azure is not always the truth. Okay. Azure is the truth. Like, that's the way it is. Like, that's how it's configured, but that's not, the truth may not be the desired state. So I'll give him that. If we're calling truth, like, this is how it currently is provisioned, then yeah, Azure is the truth. But the code is the desired state. That's what we need to get to.
It's in Azure, and if it's not Azure, then it's not running and you're not getting billed and it doesn't exist. So making changes to the portal using your preferred method. So the portal, the CLI, Terraform, Tofu, Bicep, and automation ensuring that everything is tracked and kept up to date. So this is more descriptive. We have stuff in Azure. What is the code for this if ever to deploy it again?
But that's why we maintain infrastructure as code, so that it describes the desired state. We want to quickly get ourselves out of being reliant on reverse engineering what's out in Azure.
So of course, making it fast. For unattended pipelines, slow is fine. But if you're screen sharing with your teammates and you're trying to do some stuff, you don't want things taking 7 minutes to apply when everyone's just kind of staring at your screen share. And things can become slow because big projects that contain everything. So here's some screenshots from some of the automation I did where I have 1,000 resources, which took 26 minutes. And
I've had Cassandra clusters that have 10 times that many resources. So this 1,500 resources, in my opinion, is a small project.
And of course, a few as well. So I mentioned that Terraform will do the fetch one thing and then check the next thing. And so 6 different fetches to check 6 different items versus doing one fetch that contains the 6 different items and doing that check. So playing to the strengths of the existing tooling, we can make...
Again, I don't know if I agree with the micro optimization, right? Like, you should design your context boundaries for your root modules in such a way that like you don't like bloat out of control. But like, I don't think when we're maintaining infrastructure as code for humans to maintain desired state through code, we need to maximize readability as well, right? So, I mean, yes, performance is a characteristic that matters, but I don't think we should do unnatural things in the code like we looked at earlier, like with the dictionary lookup and all that, to try and micro-optimize to get like the apply time down or something like that, right? I think there's bigger problems that you can solve just through scoping your root modules properly, rather than micro optimizations in HCL.
Make things go faster. And the other one was when you're activating PIM and it has the window where it's doing the request validation, there's this is a client-side guard before you submit a request. But if you have all of this cached, then you can kind of request and either it'll work or it'll fail. But in the happy case, which is more often than not, you request your PIM activation sooner. So this is a little outside Terraform, but it's trying to integrate the concerns, because if you are requiring PIM for everything and all your clients are also having to use it, and if that comes with a penalty of frequently having to activate rules, which is a painful experience, then it would suit us to automate that experience, which I've tried to do with that command line tooling. And this is kind of a brainstorming on what the Visual Explorer could be. So I have some parts of this working in code, but this is some more brainstorming. So you have subscriptions with some resource groups, and maybe you have a resource group where the infrastructure as code is not found, and the resource group could have a role assignment or a security group, and then you can see the members of that security group. So being able to visualize this and incorporating some other aspects. So you could do policy, having some presence in the visuals, or doing the costs, and maybe you could make the size of the resource group in the graph with how expensive it is or how many resources are inside of it. So you can there's a lot of opportunity for creating these high interpretable.
I mean, I like this idea of visualizing, and I think if we mashed up this visualizer with what's under management, this context of what's under infrastructure as code management versus not, and showing that visually, that would be great. I think a visualizer like this would probably make the most sense in the Azure portal itself. I think you'd have to figure out how to do framing, right? I think there are some places within certain resources that have visualization like this, but it would be pretty interesting if we had that context of what's been provisioned together within an infrastructure as code context, i.e. like a Terraform root module. It would be interesting to see like just what's in that one root module, right? And then maybe references outside of that, that core deployment zone, right, or boundary. You could see vertices going off to other resources that are outside of that root module that it references. That would be a very useful visual.
The resources are inside of it, so you can. There's a lot of opportunity for creating these high-level overviews that are immediately interpretable. So the conclusions: we can make it easy to transmute manual infrastructure into code, and approval-powered automations. So if a user wants to change something, then an approve or deny should be a simple action. Or if a user has already performed a change and our tooling has noticed that change, then perhaps we want to explicitly approve that or undo that if that is not a change that was approved but was performed anyways. And there's some guardrails and safety nets that can help make this possible. So through Azure policy and templates and disaster recovery and RBAC, we can give clients autonomy to deploy their own infrastructure while ensuring that we are following best practices by having infrastructure as code being a part of that deployment process.
Well, that was a bit of a marathon. I hope you appreciated my color commentary and my feedback. I think Dominic is doing an amazing job with these tools. I mean, you can really tell that he's passionate about what he's doing and doing a lot of cool stuff. Again, I want to reiterate something that I said. I think, let's see if we can pour some of that passion into one of the existing tools that we have, the Azure export tool for Terraform, and see if we can build one cohesive solution that solves this code generation problem, because I think it's one that definitely a lot of people feel. So looking forward to further conversations in the community with Dominic, with Mark Gray, with Stephen Ma about this topic. Some of the other topics that Dominic brought up were pretty new to me. And, I could tell that he'd been putting a lot of thought to how this code generation technique could support new workflows that might be distinct from traditional infrastructure as code workflows. So it was kind of interesting to hear that perspective. But one of the things that I really got excited about was this whole idea of the potential of creating traceability and discoverability from the resources that are actually deployed to the cloud platform, Azure, to the state files that maintain their last known good configuration, and to the code that maintains their desired state. I think that would be a really innovative way to empower infrastructure as code practitioners on the Azure platform. And I hope we can spark some conversation and maybe see some gears moving within the hyperscalers to start supporting some of these use cases. Let's make infrastructure as code a first-class citizen, not just something that's an afterthought. Anyways, let me know what you think in the comments below. Would love to hear your perspective. Until next time, this is the Azure Terraformer, signing off.